Bismillahirrahmanirrahim. Today my topic of presentation is hypothesis testing of one sample. Life is like a book, each day is a new page. May your book be bestseller with adventures to tell, lesson to learn and tales of good deeds to remember. Learning hypothesis testing, null hypothesis, alternate hypothesis, element of hypothesis testing, procedure for hypothesis testing, one sample t test, one sample z test. Learning outcomes. By the end of this presentation, participants will be able to describe the hypothesis testing, elements of hypothesis testing, procedure for hypothesis testing, one sample t-test, one sample z-test. Inferential statistic. Inferential statistic is actually to make judgment of probability that an observed difference between the groups in dependable or one or more group may have happened by chance. Therefore, in inferential statistics, we mainly deal with two main methods, estimation and hypothesis testing. Today, we discuss about the hypothesis testing. What is the hypothesis testing? The main goal of hypothesis testing is to make statement regarding unknown population parameter values based on the sample data. The hypothesis testing or statistical hypothesis is basically consists of two elements, two types of hypothesis. One is null hypothesis, which is the statement regarding the value of unknown parameter. Typically, the null hypothesis implies there is no association between explanatory and response variable in our applications or in our research. It always contains an equality sign, and the null hypothesis in research may or may not be rejected. It is denoted by H naught. If the population mean is equal to hypothesized mean, then the null hypothesis can be written as H naught is equal to mu, is equality sign is equal to mu naught. Therefore, null hypothesis is always denoted by H naught, and in hypothesis writing it is denoted by equality sign. Null hypothesis usually state that there is no effect, mean is 0, odds ratio is 1, relative risk is 0 and correlation coefficient is 0, mean there is no association between explanatory variables and the independent and dependent variable. Alternate hypothesis. Statement contradictory to the null hypothesis is known as alternative hypothesis or researcher hypothesis. It will always contain an inequality sign and it never contains the equality sign. Alternative hypothesis may or may not be accepted. It is denoted by HA. If we write the null hypothesis as H naught is equal to mu equality sign mu naught, then the alternative hypothesis can be written as HA alternative hypothesis is equal to mean mu, inequality sign is mu naught. And it may be mean is greater than mu naught or mean is smaller than mu naught. Therefore, we can represent the alternative hypothesis in this three form, whereas null hypothesis is always denoted by equality sign. In this way, also alternative hypothesis state that the population mean is not equal to 100. It may be also state that the alternative hypothesis that population mean may be greater than 100, or it may be as alternative hypothesis state that the population mean is less than 100. Now, levels of significance and confidence in hypothesis testing. The significance means the percentage risk to reject a null hypothesis when it is true, and it is denoted by alpha. Generally, it can be taken as 1%, 5%, and 10%. 1 minus alpha is the confidence interval in which the null hypothesis will exist when it is true. Therefore, there is situation and this is a decision. Situation is that when the null hypothesis is true and we accept it, then we is at the correct decision. When null hypothesis is true and our decision is to reject the null hypothesis, then we commit the type 1 error or it is known as alpha error. When null hypothesis is false and we accept the null hypothesis, then there is type 2 error. We commit beta error, which is also known as beta error. When null hypothesis is false and we reject the null hypothesis, at this time we also at correct C. Therefore, we can commit the two errors, alpha error or type 1 error, beta error or type 2 error. Therefore, estimation from the sample maybe point estimate. We can measure the mean, median, or change in the mean or median, or it may be interval estimation, which is denoted by 95% confidence interval or invariation. Now come towards elements of hypothesis testing. The a hypothesis testing in which there is always a test statistic, which is usually a quantity based on the sample data, and null hypothesis is usually used to test between null and alternative hypotheses. The test statistic is found by converting the sample statistic, which is maybe proportion, mean, or standard deviation, to score, which is known as it may be z-score, t-test, or chi-square. There is also a critical region or rejection region in hypothesis testing, which is the value of test statistic for which we reject the null in favor of alternative hypothesis. This is in the normal curve. The tail represents the rejection region, and the center represents the fail to rejection region or acceptance region. The rejection region is also known as critical region. Significance level: the probability that the test statistic will fall in the critical region when the null hypothesis is actually true. This is area is alpha or significance region, which show the probability that test statistic will fall in this region when null hypothesis is actually true. And this is 1 minus alpha region. Critical region: it is any value that separates the critical region from the values of test statistics that do not lead to rejection of null hypothesis. Critical region or critical line is actually the region which demarcates the rejection region and fair to rejection region or acceptance region in normal distribution curve. The critical region may be two-tailed, means that the critical region is present on either two extreme regions or tail under the curve. It is also two-tailed. For example, this is the rejection region, or it's indicate the significance level alpha, and this is the center area is total acceptance region or confidence level, which is indicated by 1 minus alpha. The rejection region is 5% and the center region is 95%. And it is the in case of two-tailed hypothesis. It may be right tail. The critical region is present in the extreme right side under the curve. It is also the right side right tail test in which the rejection region is present in the right side of the curve. The critical region may be extreme left side under the curve, and it is represented by the left side or left tail. Also, this is the total acceptance region, and there is the critical region or rejection region present in the left side of the test. P-value or probability value is the in hypothesis testing is actually the probability of getting a value of the test statistic that is at least as extreme as one representing the sample data, assuming the null hypothesis is true. The null hypothesis is rejected if the p-value is very small, such as less than 0.05 or less, which indicate that the result is statistically significant. Therefore, in hypothesis testing, following step, um, if we can quote the result there, we can always quote it in this way: reject the null hypothesis or fail to reject the null hypothesis. This is statistically correct answer. If we use the accept the null hypothesis, quote the null hypothesis, then it may lead to misleading. You always use the terms reject the null hypothesis or fail to reject the null hypothesis. Now the CN criteria. It can be done on the two methods, by traditional method or p-value method. In traditional method, rejection of null hypothesis if the statistic falls within the critical region or mean rejection region. Then we fail to reject the null hypothesis, and if the test statistic does not fall within the critical region. It also based on p-value method in which if we reject the null hypothesis if p-value or alpha value is less than 0.05. Therefore, it depends on two methods. Traditional method where the test statistic fall in critical region or acceptance region, or it may be fall on based on p-value method. If less than 0.05, then we reject the null hypothesis and accept the alternate hypothesis. This is following step for hypothesis testing. First of all, we state the null and alternate hypothesis regarding any such statement. Then we define a significance level which may be 1%, 5% or 10%. We decide a test statistic which may be Z test, T test or F test which is totally depend on the data. Then we calculate the appropriate test statistic significance level from the table. Compare the p-value with calculated value, and then p-value if more than calculated value, then we can accept the null hypothesis. If the p-value is less than calculated value, we reject the null hypothesis. This is decision we make at the end, and these are the following steps we can follow during hypothesis testing or any test, Z test, T test, or F test. This is also the same types of hypothesis, null and alternate hypothesis. You can state the null hypothesis in this way: mu is equality mu naught, or mu is less than or equal to, and in opposite side you can write like this alternate hypothesis in contradictory statement. Now question come how we select a suitable test of significance. It totally depends whether test involve one sample, two sample, or more sample. Whether the two sample are independent or interval or ratio. The choice of probability distribution of sample statistic. The choice of probability distribution of sample statistic is guided by the sample size and the value of population standard deviation. Therefore, if the population is normal, mean if the normal, then and the population standard deviation is known, then you use the Z statistic, and if the population standard deviation is known, we use the T statistic. If the sample size is greater than 30, you can use Z statistic, and if the population is more than less than 30 and is not normal, we use non-parametric test. Therefore, if population standard deviation is known, then we use, and the sample is above 30, we use the Z test, and if it is less than 30, we use the T test. And if standard deviation is not known, we use the T test. Same with sample size is more than 30, we can use Z test or T test. If sample size is less than 30 and population variance is not known, we use T test, and if population variance is known, we can use V test. Single sample comes from population in specific mean. This population mean is not always known, but is sometimes hypothesized. Single samples are measurements made on two different sets of items. When we conduct hypothesis testing using two random samples, we must choose the best based on whether the samples are dependent or independent. But in single sample test, we always compare the population mean with sample mean, and sometimes the population mean is not known and we hypothesize this. This is known as one sample test. For example, the doctors that work in accident and emergency departments work 100 per week despite the dangers of working such long duties. The sample size of 1000 doctor in emergency department and see there are different from 100 hours. In this way, we can compare the population mean or population of doctors with the sample. for example 100 hours. Now come to a t-test. T-test is after the statistician and chemist W.S. Gozer discovered in 1908. T-statistic look like T-statistic, T-distribution, and degree of freedom to determine the probability of difference between population. It is known as T-test. It is the hypothesis test that uses the T-statistic and T-distribution to arrive at a decision. When small samples are used and when the population standard deviation is known, hypothesis testing about one mean and test involving two mean is T-test. T-test is further divided into three types. One sample t-test in which we compare one mean to population mean. Two sample independent t-test. In this test we compare sample mean of same variable between two unrelated groups. It can be one tail or two tail. Two sample dependent pair t-test. In this we can compare samples means of same variable between two related groups before and after. It can also be two tailed or one tail. Today I will only focus on one sample t-test and z-test, and other type is presented in next presentation. Assumption of t-test. The scale of measurement follows a continuous or ordinal scale such as scores for an IQ test. There should be simple random sample and the data is collected from representative randomly selected portion of total population. Data when plotted should result in normal distribution, bell-shaped distribution curve. When a normal distribution is assumed, one can specify a level of probability, alpha level of significance as a criterion for acceptance. In most cases, 5% values can be assumed. There should be reasonably large sample size. But t-test can also be performed if the sample size is less than 30. A large sample size means the distribution of results should approach a normal bell-shaped curve. There should be homogeneity of variance. Homogenesis or equal variance exists when the standard deviation of samples are approximately equal. Therefore, these assumptions should meet before applying the t-test. That your data should be continuous or ordinal scale means quantitative forms. There should be normal population or sample randomly distributed, and the data should follow normal distribution graph. There should be reasonably large sample size and there is homogeneity of variance. Now come towards one sample t-test. In one sample t-test, there is one random sample of interval or ratio variable, and we compare with this sample mean with population or hypothesized mean. It can be either a one tail or two tail. Their formula is x bar minus mu under root x s square or n. This is the formula of one sample t-test, and degree of freedom is n minus 1. For example, the example of one sample t-test is that the mean waste recycled by adults in United States is more than 10 pounds per person per month. You want to test this claim and you find that mean waste recycled by per person per month for a random sample of 18 adults in United States is 12.4 pounds and standard deviation is 2.7 and alpha is 0.01. Can you support this claim? For this, we can first of all null hypothesis generate null hypothesis and claim is that mean waste recycled in US dirt is not more than 10 pounds per person per month. Here, the sample mean is 12.4, population mean is 10, sample size is 18, standard deviation is 2.7. Here, the sample size is less than 30, so t-test should be applied, and there should be one sample t-test because population mean is known, and there is one sample. Therefore, according to the formula, one sample t-test, applying the sample mean, population mean, there is calculated value is 3.64 through this formula. Degree of freedom calculate 8.917, so it is one tail test. However, the level of significance is 0.05. So the table value with 17 degree of freedom and 0.0 level of significance is 2.898 from table. And we know that when calculated value, which we calculate through formula, is more than table value, H naught is to be rejected and we accept the alternate hypothesis. Therefore, we found that calculated value is greater and table value is smaller. We reject the null hypothesis and claim that mean recycled waste for US adult is more than 10 pounds per month. Now come towards z-test. Z-test is hypothesis test procedure based on z-statistic which assume that the probability distribution of events under investigation follow the standard normal curve. Its formula is x bar minus mu or sigma x bar. Like t-test, z-test are also based on normal probability distribution. It is most commonly used statistical tool in such methodology when the sample size is larger than 30. In case of z-test, the variance or standard deviation is known, and z-test is more convenient than t-test as the critical value at each significance level in confidence interval is the sample size for all sample sizes. A z-score is a number of indicating how many standard deviation above or below the mean of population in the standard normal. Assumption of z-test, we have randomly selected one sample. The dependent variable is at least approximately normally distributed in population and involves interval or ratio scale. The data is present in quantitative form, which is all present in either interval or ratio scale. And the mean of population of raw score under another condition of independent, and we show the mean of population. We know the true standard deviation of population described by null hypothesis, and population is normally distributed. All these assumptions should be met under z-test that the population standard deviation is known, mean is known, population should be normally distributed, dependent variable is present either in interval or ratio scale, and the sample should be randomly selected. Therefore, the main type of z-test is two type, one sample t-test or two sample t-test. In one sample t-test, we compare the mean of sample with the population mean, whereas in two sample, there is two sample and we compare the means of two sample. I only focus in this presentation is one sample z-test. For example, boys of certain age are known to have mean weight of mu 85 pounds. A complaint is made that the boys living in municipal children home are underfed. As a bit of evidence, and 25 boys are weighted and found to have a mean weight of 80.494 pounds. It is known that the population standard deviation is 11.6 and level of significance is 0.05. Based on available data, we should be concluded concerning the complaint. Therefore, in this example, the standard deviation is also given and there is sufficient sample size. Therefore, we applied one sample t-test because population mean is also given. Therefore, after applying the null hypothesis, the population living in municipal children home are not underfed. Alternative hypothesis is equality sign. The boys living in municipal children homes are underfed. Given that sample mean is 80.4, population mean 85, sample size is 64, standard deviation is 11.6, the sample size is greater than 30, so we apply the z-test and therefore population mean is given, we apply the one sample z-test. After applying the formula, we value come is minus 2.8. So our calculated value is minus 2.8 and the level of significance 0.05 and it is two tail test. After minus 1.005, the closest area comes minus 47.50 and the corresponding z value in table is minus 1.96. Therefore, we know that if calculated value is more than table value, we h naught is to be rejected. Therefore, calculated value is minus 2.8 and the table value is 1.6. So our calculated value is less than the table value, so we will accept the null hypothesis. We see and the boy living in municipal children homes are not underfed. There is further example of one sample z-test. In this, the 400 male workers have mean weight of 67 inches and it is able to regard the sample as a sample from a larger population with a mean weight of 67 and standard deviation 1.30 inches and 5 level significance. Therefore, after writing the null and alternate hypothesis and x bar assuming the population to be normal, we apply the one sample z-test and after applying the formula, we see that the this is two-sided test in given and we apply the two-tailed test for determining the rejection region at pi level of significance using under normal table curve. We see that the value is more than 1.96. Our observed value of t is 1.231, which is acceptance region since r is more than 1.96. Thus, h node is accepted because if the table value is more than calculated value, we accept the null hypothesis. Therefore, comparison between Z and T test is less one sample Z test. In this sample is drawn from population whose mean is known or hypothesized. Variance is also known, standard deviation is also known. And in one sample T test, sample is drawn from population whose mean is known or hypothesized. Variance is not known. We should want to compute it. Therefore, z-test is statistical test that follows a normal distribution. T-test follows t-distribution. Z-test is appropriate when sample is moderate to large, and t-test is appropriate when sample is smaller. Z-tests are less commonly used than t-tests. T-tests are more commonly used. Z are preferred when standard deviation are known, when t-tests are preferred when standard deviation unknown. Z-test is less adaptable while t-test is more adaptable. T-test has many methods that will suit any need. Z-test find less users than T-test, and T-test is more commonly used. There are no fluctuation occur in Z-test. There are fluctuation occur in T-test sample variance. Therefore, this is a formula given one sample Z-test normal distribution x bar minus, and this is one sample T-test n minus bar. The normal distribution standard deviation is known, and this is a formula of one sample T-test. Two sample t-tests to their two mean, and their formula is x bar minus x2, pair t-test formula, and one-way ANOVA formula. Therefore, in hypothesis testing, it does not lead to proof of hypothesis. It merely indicates whether the hypothesis supported or not by available data. Now come towards MCQs. If the critical region is evenly distributed, then the test is referred to as two-tailed, one-tailed, three-tailed, zero-tailed, or right-tailed.
A.
Yes, correct answer is two-tailed because critical region is evenly distributed in two-tailed test between acceptance and MCQs 2. In statistical testing of hypothesis, what happened to the region of rejection when the level of significance of alpha is reduced? The answer depends on value of beta. The rejection region is reduced in size, rejection region is increased in size, rejection region is unaltered. The answer depends on the form of alternative hypothesis.
B.
Yes, correct answer is B. When the level of alpha or level of significance is reduced, the rejection region is also reduced in size. A professor wants that the mean score in biostatistic test would be above 70 among the students. A 60 students are chosen random from the class and given a biostatistic proficiency test. The sample mean was found 79 and standard deviation 13%. The appropriate null and alternative hypothesis to test the professor claims should be h naught mu naught is equal to 7 or mu is greater than 70 alternate hypothesis. B is equal to mu is not equal to 70 and A is greater than 70.
A. A.
Null hypothesis का denoted sign what should be the alternative null hypothesis? Anyone in the class?
A.
Yes, correct answer is A. In university population, the average score IQ is 100. A team of pharmacists wants to test a new medication to determine if it has either positive effect, negative effect, or no effect at all on intelligence. A sample of 100 students who have taken the medication have sample mean of 140 with standard deviation 40. Did medication increase intelligence? The appropriate null and alternative hypotheses to test the pharmacist claim are
A.
B.
Beta.
yes B because in this there is no direction. You want H node mean is equal to 100 and in alternate hypothesis mean is represented by inequality sign is not equal to 100. Therefore, the correct option should be B. In statistical hypothesis testing of quality of mean such as H naught is equal to mean is equal to 10 and if alpha is 5%, then 95% of time we will make an incorrect decision. 5% of time we will say that there is real difference when there is no difference. Type 1 error occur. 5% of time we will say that there is no real difference when there is a difference of type 2 error. 95% of time the null hypothesis will be correct and 5% of time we will make a correct inference.
B.
B.
Yes, correct answer is
B.
B. Because alpha is 5% and in 5% of time we will say that there is real difference when there is no difference. It is actually the type 1 error, which is also known as alpha error. 2000 women followed the keto diet for a month. A random sample of 50 women lost an average weight of 6.7 pounds in 1 month. Test the hypothesis that average weight loss per woman for the month was over 5 pounds. The standard deviation for all the women in group was 7.1. An appropriate statistical test will be z-test, t-test, z and t-test, both chi-square test or correlation.
A,
Test. A.
Because the standard deviation is
Z
also
test.
given and the sample appropriate, which is more than 50. Therefore, z-test should be applied. A researcher at a certain university found that students have above average intelligence. A random sample of 100 students' IQ score have mean score of 11.5. Is there is sufficient evidence to support the researcher claim? The mean population IQ is 100 with standard deviation is 20. The appropriate statistical test will be one sample Z test, two sample Z test, one sample T, two sample T paired sample T test.
A,
A. Sample Z test.
Yes, because the standard deviation is given and the population and the sample size is sufficient. Therefore, we apply and the population mean is also given. We apply the one sample z test and there is also one sample. MCQs number 8. The mean waste recycled by people in Lahore is more than 10 pounds per person per month. A researcher want to test his claim. He found that the mean waste recycled by a person per month for a random sample of 18 adults in Lahore is 12.4 pounds and the standard deviation is 2.7 pounds. Alpha is 0.01. After calculating t-test statistic, the calculated value is 3.64 and table value is 2.64. The decision will be to
A,
reject
A.
the
Check the null
yes,
hypothesis.
yes alpha level because in this our calculated or test statistic is more than table value. We reject the null hypothesis and we accept the alternate hypothesis. MCQs 9. Z-test is hypothesis testing procedure which is based on Z statistic and it assumes that the probability distribution of events under investigation follow the standard normal curve. In Z statistic, the dependent variable always be an interval or ratio scale, interval or ordinal scale, interval or nominal scale.
A,
Interval
Yes,
ratio scale.
yes, it should be in quantitative or interval or ratio scale. MCQs number 10. The test statistic for two-sided significant test for population is Z is minus 2.12. The correct corresponding p-value is 0.03. The decision is to reject the null hypothesis, fail to reject, accept the alternative hypothesis, reject the alternative hypothesis.
B,
B.
P-value is
Fail.
0.03. This means that it is less than 0.05 and it is statistically significant. Therefore, we reject the null hypothesis. And this is key reference.